This clip covers the important features of a sine wave. There are many different terms that we can use. I'll just stick to the common ones that you're going to need. Before I do that, you need to recall the work that's just been covered. If we rotate a single loop conductor within a magnetic field, this will produce a sine wave. Okay, so if this rotates one loop within a magnetic field, it produces a sine wave. So it's that sine wave that we're going to look at. And we just need to label up some of the key terms, some definitions. Let's have a look at that right now. So the first one is, if we look at the wave, then this is one revolution. So in degrees, that is 0 degrees. There is 90 degrees. Half a revolution, 180 degrees. Almost there, that's 270 degrees. And the full revolution is 360 degrees. So that's important. We'll deal with that later on. Becomes really crucial in some of the AC work that we're going to do. So let's talk about the cycle. One revolution of our conductor produces one cycle of the sine wave. So from there to there is one cycle. So that is one cycle. The time for one complete waveform to occur. Let's look at that from a different perspective. This takes time to produce. For example, in our main supply, we have a 50 Hertz supply. That means one of these occurs 50 times every second. We'll deal with that in a moment. But that means for one of these to occur is 20 milliseconds. So the time taken to complete one cycle, this is the time, is called T, the periodic time or the period. So the period or the periodic time, and that's in seconds, the time taken to complete one cycle. Again, referring to our main supply, there are 50 complete cycles in 1 second. So we say that our frequency is 50 Hertz. So that was number 3 on your handout. Number 4 then. Number 4 is the amplitude. So here is 0, and the waveform has a positive half cycle and a negative half cycle. And from 0 to the top there has various different names, but the most appropriate and technical name is amplitude. Amplitude, so that's from there to there. When we do some calculations and other work, we may well drop in to call this a peak value, or we might call it a maximum value. They all mean the same thing. Amplitude is the technical word that we'll use, and we'll often just in chat talk about the peak value or the maximum value from 0 to the max. Okay, so that is amplitude. So this diagram of mine is getting a little cluttered. I'll move down to this one, which is just the same. On yours, you do it all on one diagram on your handout. So let's look at peak to peak. If we go from the top of one peak to the bottom of the next peak, so we've gone from there to there, then this value, whether it's voltage or current, is called peak to peak. It's like a mountain peak. Peak to peak. So that is the peak to peak value. If it was voltage, we might write that, Vp to P. So the peak to peak voltage is what that means. Going to move on to what is possibly, arguably, the most important one that we need to discuss, and that is RMS. The term RMS refers to a particular value for an alternating wave, and the value, it's always assigned the same number. RMS is 0.7071 of whatever the peak or the maximum value is. So, for example, our 230 volt mains supply, 230 volts, is actually 0.7071 times 325. The peak value of our main supply is 325 volts, but the RMS value, the one that we normally use, is 230 volts. So not bothered about you writing this on your handout, but RMS is 0.7071. This is a very important value. We'll do calculations using that very shortly. So you've got a lot of information on your handout right now, and I'm now going to look at the last one. Fortunately on our course, this isn't totally relevant, but a waveform can take a period of time to occur, and it can be assumed to be travelling. So if it's travelling, it actually has length. So the length of this wave is called wavelength. Wavelength. And it's given the Greek letter lambda, which is pretty much similar to an upside down backwards y. I'm just giving you that for information. There's a very, very remote chance it will occur in any of your exams. Most of the time it will not. So it's one that you probably don't want to worry too much about. Okay, so that's covered some of the key terms that we're going to use in the weeks, months and years ahead.